And then to wrap up this section here, we are going to look at a few more different trig identities. And for here, we're not raising our sines and our cosines to different powers, but we're looking at cases where the angle is going to be multiplied by a number. So instead of just sine of x, we might have a sine of 3x or a sine of 5x. And in these cases, we can use one of these three identities, okay? Depending on whether we've got two sine functions, a sine and a cosine function, or two cosine functions, we will use the appropriate identity. And this you might find to be the easiest of all of the examples. So we're asked to integrate sine 3x cosine 2x dx. So I'm going to use the middle one here. There we go. My pen's working now. So that's going to be 1/2. And it says to take sine of m minus n. So I'm going to subtract. So 3 minus 2 just leaves me with 1x. So I'm going to have sine of x plus sine of the sum of them. So that's 3 plus 2, or sine 5x. If it's helpful, you can write these as two separate integrals. So you could have 1/2 sine x dx, or the integral here, sine x dx. And then do the same thing with the second one. The first one is very straightforward. When you integrate sine x, you get negative cosine x. So we have 1/2 times negative cosine x. That's going to be negative 1/2 cosine x. And I'm not forgetting the c. I'll get to it in a second. For the second one here, sine 5x, remember that inside the integral, we're going to need the derivative of 5x. So I would need a times 5 inside. We can do that by putting a 1/5 outside. So a 1/5 times 1/2 is going to give me a 1/10 in front. When we integrate sine of 5x, we're going to get negative cosine 5x. So I've got a negative, remember there's now a 1/10 in front, cosine 5x, and then plus c. And that wraps up this section. In the next section, 8.4, which will wrap up our current unit, we're going to continue with using trigonometry to help us integrate.